Hi everyone, I am Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we have gathered to discuss the topic Special Function Registers from the subject Microprocessors and Microcontrollers. So this is the outline of this video, which starts with real embedded system needs and what is a special function register and how to identify the correct special function register and what is program status word, and we are ending with the practical applications of the SFR. So what real-time embedded system need? So the embedded system should control the input-output pins, timer circuits, serial communication ports and interrupt circuits. So this is possible only with the help of the special function register. Why? Because it acts as a middleman or bridge between the CPU and the hardware ports. So this is the diagram which shows the special function register, how it connects the all other hardware ports. So what is a special function register? So SFR which controls internal hardware units of the 8051. So as we seen earlier, the timer circuit and input-output ports and interrupts and memory are the main internal hardware units, so which is controlled with the help of the special function register. So the key properties starts with the address specified for the each and individual special function register. It starts with 80 hexadecimal value up to FF hexadecimal value inside the internal RAM. So each SFR has a fixed address. For input-output port, there is a fixed address. For timer circuit, there is a fixed address likewise. So access like an internal RAM. So coming to the important SFRs. So these are SFRs are classified into core CPU SFRs, pointer SFRs and the peripheral SFRs. Core CPU SFR is further classified as accumulator, B register and PSW special purpose register. So each that EOH and FOH and DOH, everything specifies the address of the each individual special purpose register. And coming to the pointer SFR, it is classified into stack pointer and data pointer, and peripheral SFR is classified into ports starting from P0 to P3 and timer circuit, serial circuit and interrupts. So how to identify the correct SFR? So we are having several examples like LED blinking, delay and serial communication and interrupt enable. So for LED blinking, the right pin to choose is bit, that is pin P1, port P1, so in which P1.0 pin should be chosen. So for example, and another example is for delay creation, so we need to choose the pin TRO, so which shows the which selects the timer mode. TMOD represents the timer mode selection, so which selects the delay option. So and T control, so T-con represents the T control. And then coming to the serial TX, so serial TX represents the transmitting the data. So once TI is chosen, the data is transmitted. The option we are getting is data is transmitted. So SCON represents the serial control and SBUF represents the serial buffer, and the IE represents the interrupt enable. So here a global enable is nothing but EA should be chosen for enabling the interrupt option. And coming to the core CPU and pointer CPU SFRs, here the accumulator is used mainly for the ALU, that is arithmetic and logical operation. So and B register is used for the mainly for the multiplication and division applications, and PSW is used as a flag register. So for example, carry flag, overflow flag, priority flag, etc. So coming to the pointer SFRs, so which is chosen at the SP stack pointer is chosen at the top of the stack, which is used for when the processor goes to the subroutine or attending any interrupts. So likewise DPTR, data pointer SFR. It is a 16-bit address. And finally coming to the PSW, key bits. So CY, carry, and OV, overflow, RS1, RS0, and P. And finally we are seeing the peripheral SFRs. It is consisting of ports, timer, serial, communication, etc. So ports represents P0 to P3. So based on the pin control, we can choose any one of the port. And P0 open drain. So P0 will be run or used only with the help of the pull-up resistors. So or else the output is not provided. So likewise P3 which is used for giving the interrupt functions, and a timer T mode which is used for mode selection, either counter mode or delay mode. So that is selected with the help of the T mode function. And then Tcon represents the timer control unit, and then TH and TL represents that is counting starts or counting ends. So that is represented. Similarly, the serial communication. So coming to the practical applications of the special function registers. So it consists of LED or relay control. So here another application is delay generation. So with the help of the timer circuit, and another application is serial communication, and finally interrupt handling. So whatever application, we need to use special function register for controlling any other port available in the 8051 microcontroller. So this is the summary of this video. It starts with definition and purpose of the special function register, and types of the special function register, and its uses. So and we are ended with the practical applications of the special function register, and this is the assessment part here. So SFR address range is 80H to FFH, that is the topest internal RAM stage. So that is option C is the right answer. And PSW, program status word address, is starts with D0 to D7H. So B is the right answer for second question. So this is the reference books and websites we have used for this video. Thank you all for joining this video.